here we get 5 volt, here we have the ground, and here of course we get this signal. This is a data signals. Okay, this is a data signals because this data signals pass through these coils. As you see, 2 coils. Here we have a fuse resistor. Here also we have a fuse resistor, as you can see, even if we have here L, because this is a reference for the inductor, but L here means a fuse resistor. And then these 2 signals goes and coming from page 16 where we have the ICH, because the ICH is the intermediate or the bridge between this connector and what? And the CPU, or the central processing unit. Okay, so if the ICH, for example, if the ICH is bad, or the USB controller in the ICH is bad or failed, you will find that all USB connectors or ports will stop working. Why? Because these signals, as you can see here, will be missed. Then the USB connector will stop working. Yeah, you can find here plus 5 volt, no problem, but the data signals will be missed if the ICH is bad. Okay? And of course here with the same working principle, as you can see, we have the USB connector 3, as you can see, with the same pin out. Always the pin number 1 is for the VCC, pin number 2 is for the data minus, and the pin number 3 is D plus, and the pin number 4 always connected to the ground. Means here, of course, this 2 pin, the USB-D or data, is passed through some coils or inductors and some fuse resistor to protect the ICH, of course. To protect what? To protect the ICH and also to protect the device. Okay. Of course, here we have this. We have here, of course, this IC that convert this voltage, a normal 5 volt voltage, to a specific voltage, to a USB VCC. It means a voltage for USB, special and specific for USB connector. So this voltage, of course, will pass through. This is a filtering capacitor. This is a chemical capacitor or a polarized capacitor. So this voltage will pass through this polarized capacitor and just through to ceramic capacitor, and we will get a filtered voltage or a pure voltage. Okay, so this is the schematic in detail for the USB connector or USB port. Every motherboard, in every motherboard, you will find this kind of schematic. In some motherboard, it cannot contain the IC. In some motherboard, you can just find the chemical capacitor and these coils, but in some motherboard, it does not contain the IC. Okay? So let's see another schematic in order to understand deeply. So as you can see here, this is the first page of the schematic. Here we have the table of contents, as you can see, and here we have the chapters, like for example, DC battery changer, select battery connector, system power 3 volt, 5 volt, system power 1.8 volt, 1.5 volt, etc. So let's look for the USB connector. As you can see here, we have the USB connector in page 48. So let's go to page 48 in the schematic. So as you can see, this is page 48 of 63, and we have USB connector, as you can see. So as you can see here, the main working principle, we have the 5 volt, as you can see here. This 5 volt will be applied to an IC. Here we have U23 IC. Okay, so and in the out of this IC will be another 5 volt, but this time is, as you can see, USB 5 volt VCC. So The power that will be generated by this IC will pass through a capacitor, always a chemical capacitor or a polarized capacitor, in order to filter the voltage. So this is a filtering capacitor, as you can see here, okay? And then we have here another chemical capacitor or ceramic capacitor. As you can see, we have C1108, and here we have 100 microfarad, 6.3 volt. So this is the capacity and the voltage for this capacitor, 6.3 volt. Here we will get 5 volt. So automatically the voltage for this capacitor is 6.3. It should be greater than the voltage that will be passed here. We have 6.3 volt. If, for example, we will get here 12 volts in the V out, this should be more than 12 volt, about, for example, 15 volt or more, okay? And for this ceramic capacitor, as you can see, we have 0.1 microfarad, 16 volts, as you can see here. So we will get, after this IC generates 5 volt here, it will pass through this filtering capacitor, this polarized capacitor, and then a ceramic capacitor, and then we will get USB VCC that will be applied directly to this connector. As you can see here, this is USB connector, but we have here many pins. You know why? Because this USB connector is common between many connectors, okay? It is common between many connectors. There is many connectors that gathered in the same connector, okay? That's why we have this kind of connector. As you see here, we have 4 grounds, 1 2 3 4, and of course here, as you can see, we have coils. As you see, you have USB L, P2 minus and P2 plus. This is a data minus and data plus, as you can see here, okay? That we find in the center pins of the USB connector, okay?